In this video we will learn type of shear reinforcement. Last video I discussed about the shear stresses in the beam section. So in case you missed this video or did not watch this video, so there is some I button, just go and check out. Otherwise you will find some playlist, or you find that here I button, just go and check out. Hello friend, I am Samyadi, back to with new tutorial video regarding type of shear reinforcement in a RCC beam. So basically, broadly, we divide this shear reinforcement in three sections. Number one is your vertical stirrup. Number two is your bent up stirrup. Number three is your inclined stirrup. Okay. So one by one we'll discuss the type of stirrup. So first we'll discuss the vertical stirrup. So about vertical stirrup, we divide in four type. One leg, two leg, four leg stirrup, sometimes 6 leg stirrup. So what is this leg? We'll discuss, don't worry. So before jump to this 1 leg, 2 leg, 4 leg and 6 leg, we discuss some important points. Number one, dia of this stirrup is may 6 mm to 16 mm. Normal in RCC construction we provide the 8 mm bar, but some special construction, pile, dam, we go the higher bar, but mostly we do use the 8 mm bar for making stirrup. Number two, vertical stirrup, they mainly resist diagonal tension. Spacing is calculated by the design, we'll do later, but spacing at support not so close, but spacing at midspan is very close, but shear stress is maximum in the support, but our concrete is the good in resisting the shear. So these are the some 4 points for the vertical stirrup. Now we understand what is your 1 leg, 2 leg, 4 leg and 6 legs. Okay. Suppose this is your some beam cross section. In case due to some design consideration, say you provide stirrup in this way. So here is your 1 leg. Now 2 leg, again I draw a beam cross section, and normally we use the stirrup in this way. So 1 leg, 2 leg, that is why it is named as the 2 leg. What is your 4 leg? This is your stirrup, and in between there is another So here is the bar. So 1, 2, 3, 4. That is why it is 4-legged. And what is the diagram of the 6-leg? This is bar. Here is bar. Bar. Here is bar. Bar. So 1, 2, 3, 4, 5, 6. So here is your 6-leg. Okay. So this is your all about your vertical stirrup. Now we'll talk about your bent up stirrup. Bent up stirrup. What is its diagram? Suppose this is your beam cross section, this is your rod, and this is your vertical stirrup. In case this type of bar is there, that is called your bent position with a theta angle. So that is your known as the bent up bar. That is the vertical stirrup. That is your main bar. That is some angle that should be mostly 30 or 45 degree. And where we provide the bent up bar near the support. So we provide the bent up bar at support. It is a point. Angle should be, that theta should be 45 degrees, sometimes 30 or 60 or mostly 45 degree. And total bent up bar is not greater than half of total shear reinforcement. That is the consideration point. And it must be resist diagonal tension. Why? Because diagonal tension is acting 45 degree and we provide different direction. We provide it for resisting, so it is resisting the diagonal tension. And now we talk about the inclined stirrup. It is nothing but a continuous or bent up bar. That means this is your beam. You do not provide any kind of vertical stirrup. This is your rod, main bar. If you provide the stirrup in this direction, that is the spacing. This is some fixed angle. This is known as your inclined stirrup. The theta should be your 45 degree and they are resist diagonal tension but not the vertical tension, vertical crack. That is the one another issue. And here is the support. So yeah, this is the 3 types of stirrup which I discussed in this whole video. So I hope there will not be doubt. If there is some doubt, do comment in comment section. I will definitely get back to you. If you find some value from this video, so like this video, share the video with your friend circle. And if you find some value from this video, then subscribe this channel for getting such kind of content without any cost. So yeah, thank you for watching this video. In next video, I will talk about shear strength in RCC beam. Okay, so yeah, this is all about this video. And yeah, thank you for watching this video.